in this network we have to find the maximum current flowing through this branch, and also what we have to find is at what time this condition is going to achieve. Now to solve this question, we will have to use the superposition principle. Now according to the superposition principle, I'll have to first find the current through this branch by this voltage source by short circuiting this voltage source. And secondly, I'll have to find the current through this branch by this voltage source by short circuiting this voltage source. So here, if I say that the current I1 is flowing because of this voltage source when I short circuit this voltage source. Now what will happen, that whenever I am going to short circuit this voltage source, even though there is a branch for a current to flow in this direction, whole of the current will be flowing through it because there is no resistance in this path. So whatever current I1 is flowing is just because of this network part. Similarly, when I am finding the current because of this voltage source by short circuiting this voltage source, then even though there is a branch of resistance R and inductance L in this side, the whole of the current will be flowing through this branch only because there is a least resistance along this path. And hence the net current which is flowing through this middle branch is going to be I1 minus I2. So what is the I1 value? Well, I1 is nothing but V by R in bracket 1 minus e raised to power minus t by tau, or here it is L by R. Similarly, what is the value of I2? It is again going to be V by R in bracket 1 minus e raised to power minus t by tau, but here it is going to be 2L by R. So this is how you will get the values of current I1 and I2. Now I want to find the current through this branch. So that current will be I1 minus I2. So if I put these values, the equation will be V by R 1 minus e raised to power minus TR by L minus V by R 1 minus e raised to power minus TR by 2L. Now if you solve this V by R minus V by R will get cancelled out. This minus V by R, it will become plus. So if I say this as V by R, e raised to power minus TR by 2L, and this will be minus e raised to power minus TR by L. So this is the current at any instant t. Now I want this current to be maximum. So naturally what I am going to do, I am going to differentiate this. So di by dt, this should be equated to 0. Now I will take out this V by R as it is, so it will be, and if I differentiate it, I am going to get this as minus R by 2L e raised to power minus TR by 2L, and what will be here, this is minus, and it is going to be minus R by L in bracket, and this is into e raised to power minus TR by L. Now I am just equating it to 0, so V by R will get cancelled out, this R by L will get cancelled out, then this minus minus will become plus. So ultimately I am going to get this as 1 by 2 e raised to power minus TR by 2L equal to e raised to power minus TR by L. So therefore this is going to be 2, it is upon e raised to power minus TR by L, so it will become plus, and hence it is going to be e raised to power minus TR by 2L plus TR by L. If you solve this further, it is going to be e raised to power TR by 2L, which is 2, therefore TR by 2L equal to ln2. So this is going to be natural log of 2, and hence what will be the time period after which this condition is going to happen? 2L by R ln2. So this is the time after which this condition is going to happen. Now if you try to substitute this value of t in this equation, you are going to get the value of current also. So I'll just do here itself. So it will be V by R. Now if I substitute it here, e raised to power minus r by 2l, and this t is 2l by r ln2, and then minus, this is nothing but e raised to power minus r by l, and this is 2l by r ln2. So using the simple property, r by 12 will cancel out, so e raised to power minus ln2, so e raised to power ln2 raised to minus 1, and hence it will be v by r, so it is going to be 1 by 2. Similarly here r by r will get cancel out, so it will be minus e raised to power ln 2 raised to minus 2, and hence it will become 1 by 4. Therefore finally if I solve this, this is going to be v by 4r. So whichever I am finding here is the maximum current, because I am finding the current at a time when that current was maximum, and hence the answer for this is v by 4r, and hence the answer option for these questions are B and D.